Now this talk is going to be pretty straightforward as well. Heterolysis. Okay. In chemistry, that is, not biology. That means you have a molecule, you have two parts, okay? And say one part splits off from the other part, and you end up with a positive and a negative part. All right? So you have a neutral part, or a molecule, which then splits up, becoming a positive and negative part. Okay? This is what I believe is happening on the sun. Solar wind is made up of positive and negative particles. And what this does is have a domino effect on all of the astronomical matters. The domino effect is as follows. Since we have solar wind and positive and negative parts, what we have is evidence of two things. First thing is the obvious, that there are molecules in the sun, meaning the sun is very cold in some spots. That goes along well with this theory as well, because 5,800 degrees Kelvin is too hot for molecules to form. So where do these molecules come from to form the solar wind? Okay, that's the first issue. The second issue, domino effect, is that what process allowed these objects to split up to begin with? Where was the energy to split this stuff up? Okay, if the energy is too high in here for these to even form, the nuclear thing is completely out of the picture. Let's put an X around that. What it means is that you had energy from some other source splitting that up. Okay? What was that source? It was electrical current. You have electrical current slamming into that, just like electrolysis splits up water into hydrogen and oxygen, and it releases the positive and negative parts as solar wind. So in other words, the solar wind is evidence of electrical current in the solar interior. And the energy, or the strength of the electrical current to break apart this particle is known as the decomposition. Here, I'm going to erase some things. It's known as the decomposition voltage, or decomposition potential. That's the energy required to break apart that neutral molecule into both positive and negative. This heterolytic fissioning will continue indefinitely on the sun until the particles reach a more stable equilibrium, meaning once all the electrical interactions in the star die out, okay, this process will stop happening, and guess what will happen? The solar wind will be no more. There's a lot more that happens in addition to that, but basically, when you have heterolytic fissioning stopping, that means the molecules will stop breaking up. And once they form, they will stay that way, and then they'll form even bigger molecules. And then they'll start a whole line of events which form all the chemical compounds that we're familiar with on the Earth, but that's for a later talk. All right, hopefully that sums up heterolysis.